All right, in this video, we're going to be talking about partial fraction decomposition. So we're going to be taking a look at an example. But a rational expression can be often written as the sum of one or more fractions, as called as partial fraction decomposition. So in this particular case, here's an example. So notice we started off with this rational expression here, and we've broken it up into 6 over x plus 2 and 3 over x plus 1. So we basically did exactly what we did in class. We rewrote it, we broke it up. And so the individual fractions on this side are called partial fractions. So let's take a look at this example here. Let's break this up. So we want to factor out the denominator first. So here I have x squared plus 6x plus 8. And this, notice that this factors into x plus 4 and x plus 2. So now we want to write the expression as the sum of two fractions. So here's our original expression. We're going to write that as the sum of two fractions, so using the factors as the denominator, so I have x plus 4 plus x plus 2. And then I'm going to write a and b as the numerators. That's what we're trying to figure out what they are, a and b. So it says eliminate the denominator by multiplying by the LCD. So let's go ahead and take the LCD and multiply. So when I multiply this side by the LCD, which is x plus 4 times x plus 2, that entire thing is going to cancel, and I'm going to be left with the numerator, which is 3x plus 2. On this side, I'm going to multiply each individual term by the LCD. So when I multiply this side by the LCD, that leaves, but notice what I'm left with is a times x plus 3, because the x plus 4's cancel out. Then I'm left with, when I multiply this side by the LCD, notice how the x plus 2 disappear, so I'm left with b equals x plus 4. So that's what that step is going to ask me to do. Now this one says distribute and group like terms. So in this particular case, we are going to distribute out the a and the b. So I'm left with 3x plus 2 is equal to ax plus 3a plus bx plus 4b. Okay, we want to be able to group them, so we want to get all of our x's together, so like our like terms. So notice that I have an x here and an x here, so we're going to rewrite this as ax plus bx. And then notice that what I'm left with are constants, so I have 3a and 4b. Okay, and that is equal to 3x plus 2. So now we have to ask ourselves, is there any other factoring that can occur here? So notice that here in this particular space, I can pull out an x. So let's go ahead and do that. So I'm left with x and a plus b plus 3a plus 4b. All right. So now, because of this, this shows us that we have two systems of equations here that we can use. Here is one, here is the other. We just need to figure out what those equal. Okay, so this would be a plus b is equal to, now that because that x is there, that a plus b needs to equal 3. Notice 3x, here's our x component. Left 3a plus 4b then must equal our constant of 2. All right. You know what? I messed up. This should be x plus 2. All right. So now I have a system of equations here. Notice I have two systems. My two variables are x and y. So let's go ahead and solve this then. We've been working on solving systems of equations, so we can definitely solve this right now. I'm going to go ahead and do the elimination system. I'm going to multiply the top by -2, so I'd end up with -2a minus 2b equals -6. So then I have 2a plus 4b equals 2. The a's are gone. I'm left with 2b is equal to -4. So therefore b is equal to -2. So if b is equal to -2, then a must be, so I have a minus 2 is equal to 3. So therefore a must be 5. So these are the values. So this means that when I look at the fractions, right, the a is going to be 5 and then the b is going to be our -2. So that means the way that we would break this up, right, the partial fraction, we would have 5 over x plus 4 minus 2 over x plus 2. Okay. So we decompose that fraction into its parts. Let's look at an example. We'll do 2 examples, and then I want to pause and give you an opportunity to attempt it on your own, and then I'll write out some answers. All right, so let's take a look at this first example. Notice that x squared minus 9, this is the same thing as breaking this up into x plus 3, x minus 3. Well, let's start off like that. So 15 over x plus 3, x minus 3. I'm going to set that to a over x plus 3 plus b over x minus 3. Okay, so we need to find our system equation. So remember, we're going to get rid of that denominator by multiplying everything by the denominator. So then when I multiply it here, the x plus 3's go away. Oops, the x minus 3. 3's go away. But remember, I still have that x plus 3 here, and I have that x minus 3 here. So then that means that we are left with 7x minus 15. Is equal to x minus 3a plus x plus 3 equals, x plus 3 times b. All right, so here we are. And so looking at this, we're going to go ahead and simplify this out. So notice we end up with 7x minus 15 equals ax minus 3a plus bx plus 3b. So that's 7x minus 15 equals, just realized that since we're going fast, I'm dropping. This should be an a. Okay, why is that? Why is it should be an a? Because it's going to be a times this and a times this. So a times x gives me ax, a times -3 gives me -3 a, excuse me. And then I have x plus 3 times b. So then I get bx plus 3b, that looks good. So now let's combine some of these. So I have ax plus bx plus 3b minus 3a. So now we can factor out the x from this first term here. So when we factor that out, we end up with a plus b. And then I still have 7x minus 15. So now what we want to do, now let's combine these. So all right, so what we want to do now is that, notice that this is attached to the x. So this is telling us that that first value is going to be a plus b equals 7. And the second value is going to be 3a. 3a minus 3b equals 15. Okay. All right, so let's figure this out. So we can go ahead and substitute in. So we're going to have 3 times, so instead of writing a, I'm going to write this as 7 minus b. And then that's going to be minus 36 minus 15. All right, so now let's go ahead and distribute this 3. So we end up 3 times 7 gives me 21 minus 3b minus 36 minus 15 equals 0. Hi guys, I realize I can't even read my own handwriting. This shouldn't have been a 36. That should have been a 3b. So I apologize for that. So here notice that we're going to have 21 minus 3b minus 3b. So this is going to give us a negative 6b. And then we're going to have 21 minus 15. Which gives us 6, which is equal to 0. So now we can move the 6 over, so we'll end up with 6 equaling 6b, which therefore tells us that b is equal to 1. Once we know what b is, we're going to go back and find out what a is, so we can plug it back in. Let's go ahead and use this one right here. So we're going to have 1, or a plus 1 equals 7, so therefore a must equal 6. And so that's our second answer there. So it means that our fractions broken up turn into 6 over x plus 3 plus 1 over x minus 3. All right, so that's up for the first example. Go ahead and pause the video right now and attempt the second example. So go ahead, hit pause, try the second example on your own. All right, so hopefully you had an opportunity to check your work. So I hope you attempted it, and did you get this? So where I got a is equal to 5 and b is equal to negative 6. Check your work, see if you got that. If you didn't, pause the video here, take a look at the work, and see if you can find your mistake on your paper. I do want to take in a moment to look at example 3 here because it's a little bit more involved and a lot more complicated. I don't think I have enough time enough space here to go through the entire example. But we're going to start off doing the same thing that we have before. Let's go ahead and factor this. Let's pull out first the x so that then we're left with x squared minus 2x minus 3. Right? I'm going to pull out the GCF, right, the greatest common factor. Once I do that, I'm going to go ahead and factor this inside. So when I factor that, I end up with x minus 3 and x plus 1. Okay. So now what's happening here is that we're going to end up with essentially 3 variables, because look how many denominators my denominator turns into. So let's rewrite that numerator. Over the denominator, x times x minus 3 times x plus 1. All right, so when we do this, we are now going to use 3 variables because we have 3 different denominators. So we're going to have a over my first denominator, which is x, plus b over my second denominator, x minus 3. And lastly, I'm going to use c under my third denominator, x plus 1. So as you can imagine, because I have 3 variables, I'm going to end up with 3 equations, and we're looking at a 3 by 3 system here. So let's go ahead and figure out what this has to be. So when I multiply all of these by the least common denominator, right, you can see that the a is missing the second and the second and the third term. So I'm going to have a times x minus 3, x plus 1, plus b. What is b missing? B is missing the x and the x plus 1. So it's going to be b times x plus 1. And lastly, the c is going to be missing x times x minus 3. And so this is what the numerators look like. So let's go ahead and multiply this out so that we can kind of simplify. All right, so now this side stays the same, negative 5x squared plus 19x plus 12. What is that going to equal? We're going to multiply this out. So that means we're going to FOIL this and also multiply that. We're going to have to multiply that a out. But let's start with just FOILing. So I end up with x squared minus 2x minus 3 plus b times x squared plus 1 plus x, and then plus c, which is x squared minus 3x. All right, so now let's multiply our letters through. So we end up with ax squared minus 2ax minus 3 plus b x squared plus bx plus cx squared minus 3cx. Okay, so we should have something like that. Now let's go ahead and combine our like terms. We're going to combine all of our x squares. I have an x squared here, I have an x squared here, and I have an x squared here. So this is going to tell me that I'm going to end up with ax squared plus bx squared plus cx squared. Okay. And then what else do I have? So if I look here, I have a bx and a 2ax. So then this is going to be minus 2ax plus bx. And then I have an x over here, so it's going to be minus 3cx. And then the only thing I'm left with is this negative 3 here. And I dropped an a, that should have been 3a, so minus 3a. Okay. All right, so what's next? So what we're going to do next is we're going to factor. So notice how these all have an x squared in common. So it's going to be x squared, a plus b plus c, minus x, 2a plus b, minus 3a. So now we're comparing this to the left-hand side so that we can write our equations. So for our system, so notice in front of the x squared is that negative 5. So a plus b plus c must equal negative 5. So I have a so in front of the x I have 19, which means that 2a plus 3b equals 19. And lastly, I have negative 3a equals 12. And so here's our system that we want to solve. Take a moment. I advise you to go ahead and pause the video, do this 3 by 3 system, and then you should see that in your completion you'll get the following answers. But go ahead and pause first. All right, I hope you took the time to work out this problem. Let's take a look at what we have. So based off of this work of solving that 3 by 3 system, we end up with a equals negative 4, a b equals 2, and a c would equal negative 3. And so that is what was being asked of us. So that means that we can rewrite these fractions as negative 4 over x plus 2 over x minus 3 plus negative 3 over x plus 1. And so this is the decomposition of that fraction. All right, I hope you found this helpful. Let me know if you have more questions.